Hello everyone, welcome to Linked Frequency. I'm Vaibhav Sugandhi, and in this particular tutorial I'm going to explain you how to integrate two actuators and two sensors with an Arduino development board. The major reason for this particular tutorial is all about understanding the algorithm and the coding pattern of integrating two sensors and two actuators with an Arduino development board. Without further delay, let's get started. Alright, welcome back to screen, and I'm going to show you how exactly we started with integrating these sensors and actuators in this tutorial. As I already said, this tutorial is majorly focused on understanding the algorithm and understanding the process of connecting sensors and actuators together. So I have selected little bit complicated sensors in this particular tutorial so that you can understand what exactly the procedure required for integrating different sensors available on Tinkercad platform. We have selected ultrasonic sensor, and also we have selected a temperature sensor, which is only sensor available in Tinkercad, and we are going to integrate that particular sensor with Arduino development board. And along with that, we have already selected piezo buzzer, which is a simple actuator available in Tinkercad, and also an servo motor. This is SG90 servo motor, which is commonly used for hobby projects and everything. So personally I have felt very interested to integrate all these components to Arduino Uno development board so that you can understand how exactly these complex sensors and actuators are utilized when designing embedded system. However, we are going to talk about embedded system in a coming tutorial, but right now try to understand how to integrate sensors and actuators, that too multiple sensors and actuators with an Arduino development board. First of all, I have already built a circuit because we already know that in previous 4 to 5 tutorial we are exploring this platform, much more familiar with that. So I personally believe that we don't need detailed explanation for this one. And along with that, I have already built a code for this as well, because we don't want to spend too much of time on building a code, rather than we will spend much time on understanding this. First of all, we need a servo.h library because we are integrating an servo motor with our Arduino development board. Because of that, we need a servo library, which makes our life easy. Other than that, also you can write a code by yourself, but quite easy to go with a built-in library, right? And along with that, we have a preprocessor directives, which helps us to define our pins, whichever we are connecting with, means whatever sensor we are connecting, whatever actuator we are connecting, we just need to mention that specific pin number in this particular preprocessor directives. Thereafter, we have a global variables, which helps us to keep the data anywhere in the entire program, not specific to specific function that we are using. So I'm preferring to go with a global variable. Thereafter, we have declaration of these members of structure, which is related to servo motor. I think it is a little bit detailed with respect to C++ programming, which I'm not going to dive deep into, but I hope you can understand that there is a necessary of such code in this particular program. Thereafter, we have one more global variable, which is all about holding the position of the servo motor head, or maybe shaft, you can say. Okay, these are all about a very important part of the entire program. Of course, everything is very important, that's why we are using it in the simple program that we are creating now. But these parts are very important because they are the things which holds our data, whatever generated from the sensor or an actuator. Okay, thereafter we have a setup where we are going to execute only once the specific instructions which are very essential to start with the entire embedded system, or maybe whatever sensors and actuator we integrated. First of all, we started with serial.begin, which is all about UART communication. So it starts the serial monitor where we can monitor and see the different outcomes, or you can say you can print any debugging statement for the purpose of debugging and resolving some errors in your entire system. But right now I don't want to focus on that, but still do remember this serial.begin is very essential when it comes to developing an embedded system. Thereafter, we have combination of actuators and sensors, all input, output, and declaring which pin is connected with a servo motor. Quite easy to understand because we dive deep into these topics in previous tutorial. If you have not watched any of those tutorial, go back and watch them. What is the difference between actuator, sensor, and what is the principle or what is the way in which we need to use this pin mode instruction. Okay, the only different instruction that we are using in this particular tutorial is this one, calling the function within the structure called my servo, or maybe you can say it's a concept of C++, object-oriented programming. No need to worry about it much more, but do remember you have to write this particular instruction to access the servo library within this Arduino development board, or maybe you can say Arduino software as a whole. Okay, thereafter we have a buzzer pin. Then in this particular code, I am trying to explore a very important part, that is all about user-defined functions. Okay, that is a new learning for this particular tutorial. First thing, we are creating a user-defined function for everything that we are using. Even it may be a ultrasonic sensor, or it may be a servo motor, or even the simple buzzer. We don't care. We are going to create a user-defined function for that, so that you will understand how to create a user-defined function and how to call them with respect to this particular application. First of all, we just calling a function called calculate distance, which will calculate a distance from ultrasonic sensor virtually, but though it will calculate the real distance when integrated with a practical sensor and a physical component and everything. Okay, thereafter we are going to call data from a temperature sensor, which is get temp, which a fancy name which I have given for the function that I have created just below this particular code. Thereafter, we are going to print that all data in a specific format on serial monitor, so that you can visualize what exactly the data coming from these sensors. Okay, thereafter I am waiting for 1 second by using a delay function, and then I am going to change the servo position by sending this particular signal here. You can see that this value 0, whichever I am entering, or maybe 180 for that matter, is nothing but parameter parsing. I hope you guys are a little bit familiar with these point or maybe these concept. If not, no worries, you can always Google it and you can learn about that. But in brief, if I want to explain you, it is all about parameter parsing. You can parse any value in these bracket so that it will be considered as input for that particular function. I'll show you what is that function. The function name is servo position, which is created by me again in this particular program, and whenever we call that function, one parameter has to be passed within that bracket, and based on that parameter servo position will be declared. If it is a 0, then I'm calling it as open, not mandatory, but I'm just assuming when I'm sending a 0 signal, or when a servo motor is having a 0-degree angle, the shaft is located at a 0 degree, then obviously I'm calling it as an open position. And after waiting for a 500 millisecond or maybe one second completely, I'm going to create a small buzzer sound, which is all about turning on and turning off buzzer. In a simple way, I have created a function for that, but yes, that's just a calling a buzzer function. Thereafter, again I'm sending a 180-degree angle to servo motor, so that the shaft of the servo motor will rotate 180 degree. By doing so, I call it as a close position. Just assumption, no specific or logical data for that. Thereafter, again I'm waiting for a 500 millisecond or maybe a one second if it is required. Then again I'm going to call a buzzer function, which will turn on and turn off the buzzer. So this all functions, whatever we are calling in the loop function, which is a main important function for the entire program to run, because it is a by default, it is not user defined, it is by default. We have to keep a loop function, without which the program will not execute, and it will pop up an error by default, right? So keeping a loop function as it is, we are calling a different functions within that function, so that we can manage our program in a much better way, so that we can understand the code by easy method, and we can debug it very easily. So now I'll show you how I created the user defined function for this one. When I scroll a little bit down, you can see that wide calculate distance is a user defined function which I have created just now for this particular example, and within that I have inputted all the codes or all the instructions necessary for calculating a distance from ultrasonic sensor. Just by calling this particular function, we can calculate the distance by using an ultrasonic sensor which is connected with Arduino Uno development board. And obviously we need to use a global variable here so that we can access those variable anywhere in the entire program, not only in this particular function, maybe here also. There is something called a scope of variable, which is one more concept which you have to learn by yourself. Just Google it, you will understand it. It is just a very simple topic. So based on the scope of variable concept, we have to make sure that we have to use a global variable here so that we can use it anywhere in the entire function. If you don't use a global variable, if you declare the local variable within this function, that cannot be accessed within this loop function, which is mandatory and out of user defined function that you have created. So keeping that in mind, I'm using a global variable, because of which my program executes this particular instruction whenever I call this function, and it will store the result into this variable called a distance. Thereafter, we are going to get the temperature. Absolutely same method. Again, we have only two instructions here because it's reading a data from analog pin and converting it into some value based on this particular constant. So this constant I have referred from one of online website. I'll talk about that too. We need to tweak this particular value because we are getting a wrong value in a Tinkercad. However, by tweaking this value, you will get the right value, or there is a certain mathematical models you have to execute here, or you have to convert them into a form of code which will help you to bring your entire circuit ready, or maybe your accurate temperature that your sensor can able to sense. Okay, so this is just two instruction to get the temperature from a temperature sensor that we are using in Tinkercad. Make sure that again we are using a global variable here. Otherwise, you will not able to access that data after storing it into this particular variable. Okay. Thereafter, again, I'm writing one more function for servo motor. This is the concept of parameter parsing. Whenever you write something like this, which is all about declaring a variable within this parenthesis, you will get an option for parsing that particular value from anywhere whenever you call that function. Whenever you are calling this specific function called a servo position, you can also send this variable value. It may be anything. It may be 0, 1, 2, 3, 4, 5, whatever it is, because it is an integer type. If you want to receive a boolean type like either 1 or 0, then you have to change this data type to boolean. In case of this particular example, where we need to send an angle for servo motor which is ranging from 0 to 180, I have to go with integer type. Otherwise we can go with a byte type also, which is ranging from 0 to 255, but I have selected an integer type for ease of understanding, so you can explore with a byte as well. Thereafter, I'm giving a less, just a 10 millisecond of delay just for sake of settlement. When servo motor moves, it will always having a fluctuation. To make it settle normally, we are giving a 10 millisecond of delay. Of course, this 10 millisecond is not sufficient. That's why I am giving 500 millisecond again after calling this function in the loop function, which I already showed you. But just for the sake of understanding, I am keeping a small delay here as well. Thereafter, we have a buzzer function, buzzer sound, which is all about just turning on and turning off the buzzer with 100 millisecond delay in between. You can always change this delay, or you can even parse the variable here by using a parsing methodology like int sound delay. You can say sound delay. So whenever you write something like this, whenever you are calling a function here, you have to enter the delay, what delay you want to use in that function. Like say for example, I'll write it as 100. So this 100 will be passed to this particular variable, and whenever you use this particular variable within this function, it will be replicated. I mean 100 will be transferred from that function, or whenever we call that function, it will be transferred to this function and it will be inserted in this particular delay instruction. So by doing so, you can use a parsing methodology or creating a user defined function with parsing parameter. You can literally play around these concepts and understand how exactly this particular thing helps you build a big embedded system. Okay, right now I'm going to keep it very simple because I want to make sure that you understand the concept rather than making it complicated and looking like a magic to you. Okay, nothing magic, it's absolutely a knowledge. If you understand it, you can execute it. Okay, So this is all about the code part. I hope you understood it. If not, seek back to the video and re-understand that one, no problem. And thereafter we'll jump into our circuit part, which is absolutely a Tinkercad platform based circuit that we have created here. You can see that we have selected ultrasonic sensor, which is available in the part of sensor section. When I change the component section to all, you can see that there are so many components available, where we have an input section. Within that we have ultrasonic sensor, ultrasonic distance sensor. You can select any one of these because both of them are absolutely same in my concern or in my point of view, but I don't know what is the reason Tinkercad kept them different. Okay, maybe a color difference, I guess. Whatever it is. And thereafter we have one more sensor, which is all about temperature sensor, which is TMP 36. I don't know what is the reason they have named it as a TMP 36. Maybe it is a manufacturing part number, but do remember we have to use this specific temperature sensor. We have only one of them. I don't have any other variety, so we have to use this one. And the connection of this particular temperature sensor is quite easy because it is just having a 3-pin. Okay. Thereafter we have a buzzer, which is absolutely straightforward, which we already integrated, and I hope you remember that one too. Then we have one more special component that is all about servo motor, and it is available in the output section, obviously, because it is an actuator, right? So in the output section, if you scroll down a little bit, we have a micro servo and a micro servo, both of them. Again, color difference. I really don't know what is going on with the Tinkercad. Just select whatever you feel comfortable. Okay, both are same, both are having the same connection, and both works for the same code that we built in Arduino development board, or maybe Arduino IDE that we have using right now. Okay, so the connection part, I just wanted to explain you the connection part. You can see that the VCC part and ground part to be connected to the power lane, which is absolutely straightforward. Like VCC should be connected to 5 volt, ground is connected to ground. Quite simple. Here also we have a power and we have a ground which has to be connected. In this case, I'm using a negative pin of this buzzer connected to ground and the positive pin connected to one of our GPIO. The reason is I just wanted to use this buzzer as a active high configuration, which means to turn on the buzzer I have to send a high signal. I hope you remember active high and active low configuration in previous tutorial. And thereafter we have signal pin, which is signal pin of this servo motor is connected to one of our PWM pin. Why? Because the servo motor works on PWM. It doesn't work on general GPIO. We have to generate a PWM signal to control the position of servo motor shaft. So for that reason, we need to connect that particular signal pin of servo motor to PWM pins indicated by a small needle below this, below or maybe before this number. You can see this small needle here, or small needle here, small needle here. So we have a 6 PWM pins in Arduino Uno development board, or maybe Arduino Nano development board as well. So within those pin only you have to connect a servo motor or any actuator or sensor that you wanted to connect which works on PWM signal. You must make sure that you connect it to PWM enabled pin only. You cannot connect it to other GPIO and expect it to work, okay, though you are writing a proper code. Thereafter we have a buzzer which is connected to 4th pin of the Arduino Uno development board, and then we have a trigger pin and echo pin which is connected to 2nd pin and the 3rd pin of Arduino Uno development board. And also we have a temperature sensor which is an analog sensor. That's why we have connected the temperature sensor to A0 pin of the Arduino development board. Okay, so hope you guys are very clear with the circuit that we have built on Tinkercad, and make sure that you build this circuit before trying anything that we have shown in this particular tutorial. Of course, coding part you have to write it by yourself, understand it, and try to develop it by yourself and execute it. Okay, so thereafter what we need to do is we need to click on this code and copy paste the code. Of course, I have copy pasted already and tested it as well, just to save some time to explain you how exactly I have built this circuit. Okay, just come here and paste it here. Of course, I have already pasted it, so I'm not going to paste it once again. I hope you understood the user defined function that we have spoke so far, and also parameter parsing, which is concerned with respect to servo motor position. Okay, now I'm going to start the simulation and also bring this circuit a little bit easy to understand. You can see that the system is already working. Welcome to Arduino word is displayed and distance is displayed here, temperature is displayed, and whenever servo position is open, you can see the shaft is going to one side, and when servo position is closed, it is coming back to normal position. While it is open, buzzer is creating a some beep, and when it is closed, buzzer is creating a some beep. This is how we need to organize the code in the entire Arduino IDE so that we can execute whatever we want. Now I would like to show you how exactly the data changes with respect to ultrasonic sensor. I'll just click on this. You can see that there is a small little icon is given to you. Just you can change it, and you can see that there is a change in value 200 centimeter, and I can see pretty much close value we can observe on the coding part because of software conversation and everything. We are having some losses here, which is a 5 centimeter loss, which is a little bit bigger one, but I don't know whether practically this software is working properly or not. But when we keep it closer, like say for example 76 centimeter, I can see error is very less, like 74 centimeter and 6 centimeter, which is almost like equal. 75 centimeter it is now. One centimeter of difference is observed on the data that we are collecting. When you click on this temperature sensor also, you can even change the temperature value so that you can create the hypothetical situation and execute your code. If the temperature becomes this much, what should happen? You can change the temperature here, and you can see whether your code is working for that particular condition or not. So keeping all these information in your mind, I believe you understood how to execute this particular circuit and code on Tinkercad platform. I hope you understood the coding pattern here, because that is the major objective of this entire tutorial that we have created. And also I hope you understood how to execute it and how to validate it in Tinkercad platform, changing this distance value, changing the temperature value, and observing how this mechanical movement of servo motor can be done by using the code which is available in front of you. Okay, so how I exactly built this entire system, or maybe you can say a 2 sensor integration, 2 actuator integration, all together, how I combine them and how I remember all this code. Of course, I don't remember everything. I always use my laptop, which is in front of me, which is a smart device, and try to do it in a smart way. Okay, the smartest way to develop these kind of circuit, or maybe these kind of code that we are doing, is all about using the online resources. How exactly we can use online resources is all available in front of us. Let me show you on screen right now. I think yeah, you can see a screen right now. This particular circuit and this code, whatever we have written here, is available on internet. Not available exactly how you want it. Of course, available in bits and pieces. You just need to combine them, you need to integrate them, and you need to understand them and use them as per your requirement. For example, when you search on internet, you can see that create.arduino.cc is a wonderful website, where it is an official website by Arduino manufacturers or owner of this entire Arduino development board, and they have an online community where people like Akshay, Joseph, or maybe people like us who are creating a circuit and tutorial will upload their creative ideas or maybe a process to develop anything on their platform. So you just go and search for this particular website, and if you search for specific integration methodology or maybe anything that you want to integrate, you can always find a rich community support on this particular platform. Say for example, right now I have searched for integrating an servo motor with Arduino development board. So you can see that all detailed explanation is given to you, why this header file is required and how this header file is written, and all the detail, like each and everything is given to you. And below that you can even see that the code is given to you directly, but only the thing is you have to understand the code. You should not copy paste the code directly and it doesn't work. I'm repeating once again, the code that you want is not available directly on the internet or maybe in the pool of this knowledge bundle, but you can find the bits and pieces. You should know how to join them together and how to extract them as much as you need and understand them and use them as per your requirement. So now I can see that there is a servo motor code available to you. Similarly, we have ultrasonic sensor details available in the same website, but obviously you have to search in a different terms like ultrasonic sensor integration with Arduino development board, and then you can see all the detailed explanation along with the code available at the bottom side here. Okay, again, it's not a straightforward code, but you can use this code as a reference and you can build your own code. Thereafter, you have a temperature sensor integration. Again, this temperature sensor integration code is not specific to only temperature sensor. It is also having a LCD display along with that. If you don't want a LCD display, you have to identify the code which is related to LCD display and remove that code. That is how it is. Bits and pieces are available. You just need to join them. And if you search for buzzer also, you will get the buzzer integration with Arduino development board, but I already believe that you understand how to integrate simple actuators or sensors with Arduino development board. Because of that, I have not having any reference document for buzzer integration. I hope you guys understand how to collect and learn from online tutorials and online community available out there. I hope you enjoyed the entire tutorial, and I believe you're going to design your own embedded system and come up with very wonderful results at the end. Consider subscribing to our channel Linked Frequency. Hit that thumbs up button and support us by sharing this particular tutorial with your friends and family who are interested to learn Arduino development board and its coding. Tune yourself to make a difference.